do vectors in 3D today, which you're going to see that vectors in 3D are very similar to vectors in 2D. Sometimes I pop over next door to the Calc 1, Calc 2 room, and they were actually doing some 3D vector stuff. Okay, so some of you get to Calc 2, you'll be seeing this again. So vectors in space. They're going to have a direction that is in three-dimensional space, which we can see right here. The properties that hold for vectors in the plane are going to hold for vectors in the 3D space as well. Remember that the vector has many different representations, and that just depends on where its initial point is. What we're going to do is we're going to place the initial point at the origin here, and then we're going to describe it algebraically as an ordered triple. Okay, so your ordered triple for your vector is going to equal these three components. So your three components are a sub 1, a sub 2, a sub 3, which is what we have here. A sub 1, a sub 2, a sub 3. Okay? Or you could put it in component form with I, J, and K. Okay, so with I, J, and now we'll have K because we have three different components now. Okay, we have that third component that makes it 3D. So component form of a vector in space, when you have an initial point and a terminal point, then what you can do is subtract. When you subtract, it has to be the terminal point components minus the initial point components. Okay, that's going to be how you get your vector. And you can see here, this is your vector in 3D space. So they use these dashed lines to show you that this is coming out. Okay, so you can imagine it coming off the paper in your 3D space. Okay, so if you're trying to find a vector and you're given the initial point and the terminal point, you can subtract to find out what that vector is going to be. So for example 1, you're going to find the components of vector A with the initial point P, and they give you Q, which is going to be your terminal point. Okay, so I want you to go ahead and find that vector. Okay, so to find your vector, you should be subtracting. This is your x2, your y2, your z2, your x1, y1, z1. Okay, so you're going to do 5 minus 8. That's going to be your first component. Then 3 minus 6. Then 0 minus 7. Which is going to give you negative 3, negative 3, negative 7. How'd we do? Pretty good. Okay, now for B, it says if the vector B has the initial point of negative 3, negative 4, negative 8, what is the terminal point? Okay, so you're given the vector and you're given a point. You have to find the terminal point. Okay, so remember that to find the components of the vector, you just have to subtract the terminal point and the initial point. Okay, so the vector component, this is your a sub 1, this is your a sub 2, this is your a sub 3. Okay, those are your components. So for this is B, this is your B sub 1, your B sub 2, your B sub 3. So in order to get 3, what you had to do was subtract x2 minus x1. So if b sub 1, the vector, equals x2 minus x1, your initial point, is that going to be filled with your x sub 1 or x sub 2? Is the initial point the first one or the second one? The first one, right? Initial is going to be the first, so this is your x sub 1, y sub 1, z sub 1. Okay, so 3 is going to equal x sub 2 minus negative 3. Okay, or 3 is going to equal x sub 2 plus 3. If I solve that for x sub 2, what would I get? I get 0. Now really, what I ended up doing is I just added this over, right? X sub 2 is going to equal b sub 1 plus x sub 1. That's why you can always add them together, because of this setup. Okay, so if you had y sub 2 plus your 4 minus negative 4 would be plus 4. Okay, you could get your y sub 2 as negative 4. Okay, so because of this setup, you can just add b sub 2 plus y sub 1. Okay, so 0 plus negative 4 is going to be negative 4. And then my last component is just b sub 3 plus z sub 1. So negative 4 plus 8, which is going to be 4. So that's my z sub 2. Okay, so then your vector is going to be, or sorry, this is not a vector. So you're trying to find the what? Terminal point. Okay, so if you're trying to find the terminal point, we have to put that in the proper format. This is going to be 0, negative 4, 4. Okay, so again, you can just get that by adding. 3 plus negative 3 is 0. 0 plus negative 4 is negative 4. Negative 4 plus 8 is 4. I just want you to understand why you can add them together. It's because of this equation, okay, that you can set them up and add those together. Okay. All right, then the next thing we're going to talk about is the magnitude of a vector in 3D. Do you guys remember what the magnitude is of a vector in 2D? What's the magnitude for a vector in 2D? Yeah, the square root of a squared plus b squared. Okay, so these are 3 components. Okay, before they were a and b, now it's a sub 1, a sub 2, a sub 3. So the magnitude is going to be equal to the square root of a sub 1 squared plus a sub 2 squared plus a sub 3 squared. Okay, so for example 2, it says find the magnitude of the vector and then give an exact answer. Okay, and in grading the quizzes, I can see that some of us still don't understand what the difference is between an exact answer and an answer that's not exact. Okay, what is the difference between an exact answer and a non-exact answer? Okay, so if it's not exact, it's going to be a rounded decimal. If you're taking the square root and then rounding what that is, that's not an exact answer. Okay, you'd have to leave it with the radical. And of course we want it to be simplified if we have that. Okay, so to find the magnitude of vector A, I'm going to do the square root of 3 squared plus negative 4 squared plus 12 squared. Okay, so each one of those components. Okay, so 3 squared is going to be 9, 4 squared is 16, 12 squared is 144. Let's add this mentally. So what I would do is I would add the 6 first, because 144 and 6 is going to make what? 150. So then I'll add the 10, which is 160, and then I'll add the 9, 169. And 169 is a perfect square. Yep, good. Okay, so then the magnitude of that vector is 13. Right? If this was not a perfect square, we would see if any perfect squares went into this value, and then we'd simplify. Okay. All right, let's turn it over. Okay, so algebraic operations on vectors in 3D. Okay, this is the same as 2D. The only difference is now we have that third dimension. So to add, you're adding the first components together, the second components together, and then the third components. Same with subtraction. And then if you're multiplying by a scalar, then you're going to multiply everything by that scalar. So for example 3, we're given u and v, and then we have to find u plus v and u minus v, and then 2u minus 4v. Okay, so I'd like you to try those by yourself. And then if you get stuck, you can follow along with me. Okay, so when you're doing the u plus v, you're just going to add these components together. And this is going to be a vector. So negative 3 plus 4 is going to give you 1. 0 plus 1 is going to give you 1. 2 plus negative 2 is going to give you 0. We're going to subtract. Okay, so it's u minus v, so I'm going to start with the u. Negative 3 minus 4 is negative 7. 0 minus 1 is negative 1. 2 minus negative 2 is really 2 plus 2, which is how I'm going to get 4. Okay, and then I also have to find 2u minus 4v. What I like to do first is the 2u. Okay, so if I multiply everything by 2, I'm going to get negative 6, 0, and 4. If I multiply everything in v by 4, I'm going to get 16, and then 4, and then negative 8. Okay, so now what I can do is I can just subtract. All right, so then this is going to be my 2u minus 4v. So negative 6 minus 16 is going to be what? Negative 22. 0 minus 4, negative 4. 4 minus negative 8 is going to be what? 12. Okay, questions for me so far? All right, then we're bringing back our good buddy, the dot product. So the dot product for 3D vectors, if you're given A and B, your dot product, again, is the same as it is in 2D. It's just now we have that third dimension. Okay, so it's going to be the product of the first components added to the product of the second components added to the product of the third components. All right, so for part A, I'm going to multiply negative 2 and negative 4, which is going to give me 8. I'm going to add that to negative 3 times negative 4, which is 12. And I'm going to add that to 7 times 4, which is 28. So 8 plus 12 is 20. 20 plus 28 is 48. Okay, so for part A, 48 is your dot product. Now given to you in the form with I, J, and K. If you want, you can write it in terms of vector/component form. Okay? Because I is going to tell you what the first component is. Notice how I don't have an I for B, right? So if I don't have an I here, then what's going to be my coefficient of I? Zero. Yep, okay, so then it'll be 0. So I'm just going to write this vector as 0, 2, and then 7. And then this vector would be negative 1, 2, and 3. And then I can find the dot product from that. Okay, so 0 times 1 is 0, 2 times 2 is going to be 4, 7 times 3 is going to be 21, which is going to give me 25. Hey, notice that I don't multiply any of the variables. I'm not multiplying J or K. That is just the form that it's in. And then your A sub 1, your A sub 2, your A sub 3 are the coefficients of those variables. Okay? All right, so then the next thing is the angle between two vectors in space. Which again, doesn't this look familiar? The cosine of theta equals the dot product over the product of their magnitudes. Now, it also says that in particular, U and V are perpendicular or orthogonal if and only if the dot product is 0. Did I mention, when the first time we did this, did I mention that we were going to talk about how another word for it is orthogonal? Okay, so perpendicular and orthogonal are going to mean the same thing. So if it says determine if they're orthogonal, that means you're going to determine if they're what? Okay, let's try that. So if the directions tell you that it's orthogonal, then what does that mean? Perpendicular. Okay, and what's another word for perpendicular? Orthogonal. Let's try it with some gusto this time. Okay, what's another word for perpendicular? Orthogonal. Okay, good. Okay, so make sure you pay attention because some of your directions are going to say that. Okay, determine if they're orthogonal. All right, so for example 5, it says determine whether or not the vectors are perpendicular. So to figure out if they're perpendicular, all we have to do is find what? What do we have to find to determine if they're perpendicular? What? Okay, which is the dot product. Okay, all we have to do is find the dot product. Okay, so if the dot product is what, then we know that they're perpendicular. 0. Okay, so go ahead and find that. Okay, so to do the dot product, 3 times 3 is going to be 9. Negative 1 times 6 is negative 6. 2 times negative 3 is negative 6. So this is like negative 12. 9 minus 12 is negative 3. Okay, so your dot product is negative 3. Okay, so negative 3 does not equal 0. Therefore, the vectors are not perpendicular. Right? So if you did want to find the angle between them, you could use this formula. And that's what we're going to do for example 6. So find the angle expressed in degrees between U and V when you're given U and V. Okay, so the first thing we want to do is find the dot product. Okay, so 4 times 2 is going to be 8. Anything times 0 is 0. Anything times 0 is 0, so your dot product is going to be 8. Okay, then I also have to know what the magnitudes are. So I'm going to find the magnitude of u, which is going to be the square root of 4 squared, which is 16, plus 0 squared, which is just 0, plus 2 squared, which is 4. Okay, so the square root of 20. And then for v, I have the square root of, 2 squared, which is 4. Negative 1 squared, which is 1. Okay, which is going to give me the square root of 5. Okay, you don't have to simplify this because you're going to be substituting that into your formula. So your cosine of theta is equal to the dot product, which is 8, over the product of root 20 times root 5. Now, what do you notice about this? Root 20 times root 5. What's that going to be? Yeah, it's good. And if you combine them, what's that going to be? It'll be the square root of 100, which is 10. And then 8/10 is going to reduce to 4/5. The only reason why I do that is because it's going to be a lot simpler to plug into my calculator. Okay, so that means if the cosine of theta is equal to 4/5, all I have to do is the cosine inverse of 4/5. Okay, and then you'll get 36.87 degrees, which is about 37 degrees. Okay, so that's going to be your theta value. Okay, questions for me on that? Alright, I'm going to write down your homework, and then I'm going to clear everything off your desk except for a correcting utensil and a calculator. And we're going to go over your quiz.